All right, next one. Transform the following system of equations into matrix vector form. So this is my matrix, and this is my B. This is my coefficient matrix, and this is my B. I usually ask you to do that. It's a good habit to always extract the coefficient matrix and the B separately. And what you want here, what is wanted here is that AX equals B. The X is given to you. I usually have you on in-class assignments write down this X. And then the B goes on this side, so I put it in orange there. And pink or purple, you have the coefficient matrix here. What's the determinant of the coefficient matrix? Well, let's take a snip. I don't do anything by hand if I don't have to. So let's take this coefficient matrix and put it on Mathematica. So one thing I wish I hadn't done is I sometimes call the augmented matrix A, but I shouldn't. A is designated usually as the coefficient matrix. So let's input A as the coefficient matrix, insert, table matrix, new, and this is a 2 by 2. My cat is, the reason I don't have my camera on is the cat is walking everywhere. You might have heard him purring on the video already. All right, so let's put this in. 24, 32, 30, and 40. And shift enter. That gives you A. Now, the determinant would be det A, capital, and it's 0. So I would put here the determinant of A is 0. Realizing you won't be able to use the matrix inverse method, why are they saying that? Well, if A has no inverse, how can you rewrite as X, the vector X is equal to A inverse B? Why did I teach you to do inverse if it's not scalable? Well, because the inverse is important. It motivates you of why you're doing what you're doing. Whenever the determinant of a matrix is 0, of a square matrix is 0, it's not invertible. So those are the same two words. And if it's not invertible, it's a lot like the number 0. You can't divide by 0. You can't find an inverse for anything that has determinant 0. Unlike the number 0, there's a whole bunch of matrices that have determinant 0. But then that means that you're going to have to put this in augmented form and then row reduce it. Because you don't know if you have no solution or the infinite number of solutions, and those infinite number of solutions are particular. For example, here for a 2 by 2, it'll be in the form of a line. But with a 3 by 3, it could be in the form of a plane, it could be in the form of a line, and there's so many different directions those lines could go in 3D. You have to actually give what the formula for that infinite number of solutions are. All right, so what they want is the A matrix on the left side, the B vector on the right side. And so the A goes down here, and there's a line. You see that line here, and then B goes here. When you put this on Mathematica, you cannot actually put the line.